Alright guys, hello, welcome back to this very dead channel. On today, my friends have brought to attention to me that I have been too lucky. So I'm gonna do a video using high-level mathematics to prove either my luck is above average or below average, I guess. And here it is. Alright everyone, so let's start off the significance testing. So, first of all, you need a graphing calculator. TI-84 plus EE works pretty well. Alright, so this test, I will be farming melons in my farm that I built. And yeah, so my melon farm, it's 2 plots with 19 rows, and that is times 2 for 2 melons per row. Times 3 because it has 3 layers, and then times 92, which is 92 blocks per row. And so this gives us a total melon broken of 10,488. And so because I'm wearing 3/4 croppy armor at this time of experimenting, it has a 0.02% chance to drop a squash per crop broken. And this is important, so we can, because we have a success percentage, we can model this drop chance distribution by approximately a binomial distribution, right? Okay. And so using the 10,488 as the trial number, because that's the entirety of the farm, and using 0.02% chance as the success criteria, I'll display it on your screen what the binomial distribution is. And so our expected value with this binomial distribution is simply the number of trials multiplied by the success percentage, which is 2.1 per 2.1 squashes. So it can be expected that with a complete farm, after I farmed everything, that the expected drop of a expected number of squashes dropped should be around 2.1. And so we can use a t-test then to test the significance of my luck, right? Okay. So throughout farming melons, I have collected data, and here I will display all the collected squash data from my experiments farming my farm. And so from that, we can then use the TI-84 and go to t-test and go to data, and we can input all the values into list 1 with a frequency of 1, and the mu 0, which is the null hypothesis, is going to be that my drop chance follows the expected value of drop, which is 2.1 squashes per farm that is actually farmed. And the alternate hypothesis that we're trying to test is that my luck, which is the true mean of my sample, is actually higher than the proposed 2.1 expected value. So we're gonna select greater than null hypothesis, and if we calculate that, well, we get a p-value of 0.0001115. So let's say we're conducting this test to a 5% significance level. Then the p-value that is smaller than 0.05 would be considered significant. And from my t-test results, it can be seen that, well, my farm is so much more, makes so much more significant, it's more significantly making more squashes than the expected value. So yeah, I guess this proves that I am indeed more very lucky, as my friends have described, with a mean number of squashes dropped being 4.86 repeating, and that is way higher than 2.1. So I guess the test turned out significant, and I guess if you learned how to do this, that's cool, I guess. Good to know that I'm luckier than other people.